Here we are in Chapter 7, dealing with continuous probability distributions. And the idea there is that we cannot list all the possible values because there's an infinite number of possible values. And because there's an infinite number of values, the probability of each individual value is virtually zero. So what we do instead is we determine the probability of a range of values, which is different than what we did last chapter with discrete probability distributions, where you could determine the probability of a particular value. Say you tossed a die. You knew that there's 6 possibilities, so 1 in 6 chances that you'd roll a 1, for instance. But that's not the case with continuous. You can't count the number of possibilities, and so each individual value is virtually zero, and we think about it in terms of a range. And the first type of distribution we look at is the uniform distribution. We're also going to be looking at the normal distribution. But with the uniform distribution, there's a range here from A to B, and the probability is equal anywhere within that range. And so we use this equation here, the function of x is equal to 1 minus b minus a. Well, to make this more understandable, let's look at problem 7.2, which deals with the amount of time it takes for a student to complete a statistics quiz. We know that it's uniformly distributed between 30 and 60 minutes. And one student is selected at random. Find the probability of the following events. So the first one is that the student's going to require more than 55 minutes. But before we get to that, we need to calculate the function. So in this case, the function of x is equal to 1 minus b minus a. In this case, it's going to be equal to 1 divided by 60 minus 30, which is going to be equal to 1 divided by 30. And so to actually, so we're going to use that 1 divided by 30 in the calculation. So in this case, the probability that the student requires more than 55 minutes to complete the quiz, the calculation is going to go like this. It's going to be 60 minutes minus 55 times 1 divided by 30. And that's going to be equal to, and now we're just going to do this calculation, it's equal to 60 minus 55 times 1 divided by 30, which gives us 0.166667. So the probability then of it taking more than 55 minutes is that 0.166667. Part B, the idea is the student completes the quiz in a time between 30 and 40 minutes. So greater than 30 but less than 40. So in this case, it would be 40 minus 30 times 1 divided by 30 is equal to and here we'll do that calculation. It's equal to, and 40 minus 30 times 1 divided by 30 equals 0.3333. So there you go. Pretty straightforward. It's just making sure you do that function calculation for a uniform distribution. And then we've got the question here of the probability of it taking exactly 37.23 minutes to complete the quiz. And we know that because this is a continuous probability distribution, that probability is going to be 0, that it's going to be exactly that, because again, we're calculating the probability of a range. The range for A was between 60 and 55. It was between 40 and 30 for part B, and for C, it's actually equal to 0. So that's it for the uniform distribution. I'll be back to talk about normal distributions first, just some of the characteristics of that and how that functions, and then we'll look at problem 7.4 as well.